Good morning or afternoon, girls and boys. Today we are talking about lesson 5, and it's entitled "A New Way to Interpret A over B." And you guys are a little bit ahead of the curve on this because we've talked about a fraction bar being a division bar for quite a while, and we'll continue to. Back when Abe Lincoln and I were in school, we used to call these complex fractions, a fraction within a fraction. And you can see by the learning targets that we have, we are going to understand the meaning of a fraction made up of fractions or decimals, like 2.1 over zero point zero 0.07 or 4/5 divided by 3 seconds. The other learning target is that when you see an equation, you can make up a story that the equation might represent and explain what the variable represents in the story and solve the equation. We did this a bit in lesson 4. So this will be a continuation to some extent of that. And I enjoyed some of the stories I was reading on Friday for the class that did lesson 4 on Friday, or last Friday, the 20th. So in the first little exercise here, we're going to solve each equation. We're going to do this together today. So let's look at the first equation. It's 7/100 equals 10 times whatever m is. And we want to solve for the equation. Now notice that the 10 is attached to the m through multiplication because there's no symbol between it. So we're going to divide by 10 both sides. So we're going to divide the right side by 10. We're going to divide the right side, this entity, by 10, and also this by 10. So, and that's going to be equal to m. So when we divide this side by 10, we're left with just m. And here we have 7/100 divided by 10. And of course, we know that when we do that, when we're dividing by 10, it's really just a movement of the decimal to the one place to the left because of place value. So the answer to this is that m would be equal to, I'm going to pause so that you can try to figure it out yourself, but m would be equal to 7/1000ths, or 0.007. Let's try the next one. I'm going to pause for a second and then we'll talk about it. So go ahead and try to come up with what you think the answer might be, and then we will talk about that. Okay, so we're looking for some number when added to 7.2 that equals 10.1. And quite frankly, we could just make a guess, or we could just simply subtract 7.2 from both sides of this equation. And it is indeed an equation because there's an equal sign. So we could subtract 7.2 from 10.1. And when we do that, we come up with a value, and then we put it back into the equation and see if it fits. So what do you think? I'll give you a moment or two to try to do that on your own. So you probably came up with 2.9, and you'd be right if you did that. So let's put it back into the equation and see if it works. Is 2.9 plus 7.2 equal to 10.1? And of course, the answer is yes. So now let's look at 5.2. So 5.2 says that solve each equation. So again, I'm going to have you pause the video and go ahead and try to solve these on your own. But let's do the first two together. So this says 35 equals 7 times some number. So what do you think that some number is? Exactly, 5. So because 7 times 5 is 35. Now, you could do that by a guess and check strategy or a basic math facts in many cases, many times. But we could also do this. We could also divide both sides of the equation by 7. Because if we take this and divide it by 7, we're left with just x. And then we divide the other side by 7, and of course 35 divided by 7 is 5. Let's look at the second one. 35 is equal to 11x. 35 is equal to 11x. Now, 11 is not really a whole number factor of 35. So this is going to be a fractional or decimal amount, but we needn't be afraid of it. So we can just, again, divide both sides of this equation by 11. We're left with x on this side. And of course, 35 divided by 11 is 35 11ths. And 35 11ths, we could, I'll have a whiteboard for the next video. But 35 11ths, we can convert into a mixed number. So 35 11ths is in fact, I'm not sure if you can see this, maybe upside down, but it can be converted into a mixed number. So 35 11ths is a correct answer, it's just not in the best form. So we have to determine how many times 11 can be subtracted from 35. And of course, the answer to that is 3. And then you're going to have 2 left over. So the answer for number 2 is going to be 3 and 2 11ths. So go ahead and give 3, 4, and 5 a try, and then I will post those responses, those answers a little bit later. And also try to read through the lesson summary as best you can. And then, of course, I'd like you to do the practice problems 1, 2, 3, and 4, and I will post the answers to those a little bit later. And then, of course, our new favorite thing to do, right? We're going to complete the exit ticket and make sure you submit that to me through Google Docs. I would like you to keep either your math notebook if you have it at home or a math folder. I'm referring to it as the remote folder because you may not have had your actual supplies, but that's okay. Please hang on to that, and periodically I'll ask you to take a picture of it. That's especially true if you're having trouble, because that way I can help you a little bit more easily. All right, I hope you have a wonderful day, and best of luck. Hope everybody in your family is well as well.